top of the head. I'm going to try and keep this one under 5 minutes, David. Can you time me and tell me if I'm under 5? Because we've been doing too much talking. Not enough. Letting you work. So, factorising. It's when we divide numbers by the same numbers, so 2 or more numbers by the same value. Cool? So if you have a factor, let's run through the factors of 8, for example. We've got 8 and 1, 2 and 4, correct? 16 has got 4 and 4, or just 4. 8 and 2, 1 and 16, correct?
Yes.
All these different numbers have a whole set of factors. So when we look at 2 numbers, sometimes they have factors that are in common. We call these common factors. So if I look at 16 and 4, what are the common factors? What are the things they have in common? I've actually missed one, but what are the ones they have in common? They both can be divided by 4, and they both can be divided by 2. They can also both be divided by 1, but that doesn't really help us. Cool? So, they've got some common factors, and it's really, really important to help us understand how we can simplify sums, because this is really, really important later on. I know it doesn't feel really important now, but it does become important as we go down the track. And we're just knocking iPads down, because I know we're doing our work, which is good. I like to see a bit of motivation. For 3.5 more minutes, I need your attention. So, to get our expression in the simplest form, we must divide by the highest common factor. So if we're really struggling with this, we could write out all the common factors, and then what do? Pick the biggest one. So what's the highest common factor of 4 and 16? 4, correct? So in our first exercise, we're being asked to find the highest common factor. Really, really simple. We've got 16 and 4. What's not so simple is when we've got, for example, 5a and 15ab. Why is that more tricky? Let's see that.
Did you have to take into account for the letters?
Yeah, so we've got algebraic terms, letters, and we've also got some numerical values there. Of the numerical values, what's the highest common factor there? 5. So we can see that 5 is the highest common factor. But is that it?
No.
Because we can also divide both of those numbers by something else. What can we divide both of those numbers by? A. Very good. Would that still be the highest common factor if that was my expression?
Yes.
Yes.
Yes. Yes. Okay. I can prove that using distributive law. So, let's see what happens. I'll just go back to my original example. Oh, why don't we try that new example? We'll keep that as our example there. So those 2 numbers, if I had them as plus, as an example, if I wanted to take the highest common factor out, what's 5a divided by 5a?
1.
Plus 15a squared b divided by 5a. Now that sounds really complicated, correct? We went through yesterday, how do we solve that? What do we do? One at a time, correct?
Yes.
So let's start with the numbers. 15 divided by 5?
3.
Okay. A squared divided by
A.
b divided by, well, nothing.
B.
Which is b, correct?
Yes.
So we've used the distributive law with our understanding of common factors to really simplify a process that can be quite complex. Now, if you're not getting it, don't freak out. Don't freak out. If you are getting it, awesome. But using algebraic terms like that's new, and it will take time, but I'm hoping once that penny drops, we'll find it really easy. Now, the difference between finding the highest common factor, how am I going for time? 1 minute. The difference between finding the highest common factor is just that between these two, what's my highest common factor? 5a. The difference between factorising and that, this is factorising. Cool?
Yes.
So I'm using the distributive law to represent that expression. Now that is powerful. I don't really, you'll find out why later on, but that is a powerful technique and you will use that a fair bit. Cool? All good. Let's repeat it.